Leanne being one of the only like female captains on the entire show, that's one of the I feel like that's a big part of who we are as a team, and we wanted to represent that. And so the Valkyries are these female Norse warrior goddesses that would fly down from Valhalla and choose who lived and who died on the battlefield, and sort of that sort of image of like these powerful goddesses coming down and figuring out and like choosing who would go to the Valley of the Slain was like a really great, scary image.
Right now, we're most excited about Team Questionable Designs, and we want to hear all about your experiences with Battlebots and Valkyrie, the beautiful Battlebot that's here tonight. Take it away.
All right, thank you.
Yeah, Valkyrie actually lives here at Artisans Asylum. We have a lot that's made here, which we'll get into. And yeah, we are 3 of the members of Team Valkyrie. We have some teammates that are missing currently, which I can go into. Yeah, there's a bunch of us. We actually have a way larger team this year. Everyone had their little part that they played, but yeah, it's me. Who's missing is Amanda, our main welder, fabricator, Fred, our driver, and weapon assembly designer. Aaron, who's always been backup driver and good friend of ours, and Alan, who did a lot of fab and some welding for us also, and he's still a student. And then also...
Yeah. So my name's Alex Crease. Basically my job is making the robot look pretty, and I did a lot of the system level design, so the overall shape and sort of the style of the robot, and sort of figuring out how we were supposed to take all of the electronics that run the Battlebot and get them into that shape, which took a long time.
I'm Brooks Willis. I mostly worked on the weapon assembly with Fred, and then I also designed the blade that you can see here and up in that picture there, which is one of our more analytically designed blades.
Yeah, which does have a part. And yeah, I also did the drivetrain and our newer bar, which we'll get into a little bit too.
And do you run the team?
Well, yeah, I run the team, and there is a lot with management. I do engineering management for my main job, and so it's a lot of similar stuff of like accounting, project management, making sure everyone is happy with things, addressing any issues that come up off season, in the season, whatever. So, yeah, it's a bit of work. If anyone is watching this season, there's a clip of after our fight with Hypershock where Will, captain of Hypershock, gets pretty teary-eyed, and I think most people that do BattleBots could associate themselves with just like how much you have to put in for time, money, sanity, etc.
Yeah. Sleep or lack of.
Yes.
And a little bit of blood.
Yep.
Just a little. Yeah, do you want to talk a bit about just the general tech specs of Valkyrie and sort of what makes Valkyrie unique?
Sure. Well, I touched on this when while we were having technical difficulties, but reiterating. So our weight class is 250 pounds. We are a stealth fighter, jet-styled undercutter, as you can see. Our blade is 65 pounds, or bar, depending on what we're running. It spins about 200 miles per hour at the tip, and is ran by a 40 horsepower electric boat motor. So it has a bit of punch to it. We are proud to say that we do more damage to ourselves than opponents, and we actually, in general, just wreck anyone that has to go against us, and generally we're one of the more feared robots whenever someone's like hoping not to get matched against us, which is generally a compliment.
Have you ever considered painting your blade to match the BattleBox floor?
Ooh. That's a great question. I've thought about it. We thought about it. I know last season, Icewave, one of the other robots, the horizontal spinners on the show, they actually painted the tips of their weapon to match the BattleBox floor so that their opponents couldn't see it. But they also couldn't see it either, so they actually had a pretty nasty late hit in one of their fights last year because they couldn't see the edges of their blade. So that's kind of one of the reasons why I'm averse to it, is sort of we know where our weapon's going to be and we know where we're going to hit. Thank you. Great question, though.
So we've been at Artisans Asylum pretty much since the conception of our team. We actually, our team, Questionable Designs, was assembled a year before BattleBots came back. We had heard murmurs that there was going to be a show, and we wanted to make sure that everyone played nice together. I assembled the team. Alex was my intern 5 years ago. And so I wanted him on my team because he was a big fan of Battlebots. I was like, hey, I'm going to start a team. Do you want to join it? And it's been sort of a mix of adding, subtracting, and so on. Like Brooks and Alex went to school together and they're good friends. So that's how I met Brooks. We're all first alumni, like a robotics program for high school students. I think the only ones on the bigger group of the team is just Aaron and Alan that didn't.
Yeah.
And then, we have a bunch of pictures of the smaller weight classes. Our first Robo Games visit with Boris in the top right. Fabricating parts, even with a broken foot on the bottom left. Amanda working on welding stuff. And then our crate from last year on the bottom right. And then your robot in the top center.
Yeah. So we've, as Leanne said, like we've been at Artisans since we were formed as a team, basically. And even before Battlebots, we were building these smaller robots, and so we'd use the tools and resources here. There's a robot fighting event that happens here every few months called Mass Destruction, and we actually competed in that. The first version, the first idea behind Valkyrie was actually a 1-pound robot that we have over here that I can show later, and I competed with it at Artisans, here at Artisans, and that's sort of what got the idea kicked off. We sort of had this idea, I made a little 1-pound version of it, and we decided that we wanted to scale it up to 250 pounds. And so over the next 3 years, we spent a lot of that time working at Artisans, building different robots, scaling this design very slowly up from 1 pound to 250 pounds, and using a lot of the facilities here, like the mills, the welding shop, a lot of the paint studio. We spent lots of long nights in the paint studio
There's
this
a
year.
lot of regulars that don't like me very much anymore.
And sort of using the resources to build Valkyrie. So we're always here, and now we have Valkyrie on display here as well. All right. So now we're going to talk a bit about why we decided to design Valkyrie, what sort of our ideas were coming in thinking about Battlebots. As Leanne mentioned, for a while we've been talking a lot. We sort of formed as a team before we knew Battlebots was coming back, and we all just knew that we liked building tremendously terrifying robots. So this was the first rendering we made of Valkyrie that Brooks actually made as our application for Season 3 of Battlebots. And it sort of highlights a lot of the parts of the design that we thought were special. So do you want to talk a bit about the basic ideas that we had going into Battlebots, what we wanted to do?
Sure. So purely aesthetically speaking, the way we actually started designing and got to this shape is we took a top-down view of a B-2 bomber. We just dropped it into CAD, sketched it out, deleted the image, and then went from there. So this is actually the same proportions as a stealth bomber, because that was the original idea. Was we wanted to go with like a high-tech, sleek, like black kind of look, which we ended up with. The other thing we were going for was a very sort of nimble design, which is why the wheelbase is so far forward on the blade, and the blade is so large as compared to the rest of the robot. So there's some interesting dynamics in that we can talk about a little bit later. But sort of from a high level, one of our design goals going into this was make the weapon as large as we possibly can. And just really, every single time we could optimize something on the robot, add a little bit to the blade, we did it. And that's how we ended up with such a, frankly, silly weapon.
Oh, it's fantastic. We have
It's
one of the
so good.
further reaches for robots, and it's one of the things. Like I actually, Tombstone, one of the fan favorites. It's been around forever. I'm good friends with Ray. I was like, hey, Ray, what's the reach of your weapon bar? Just, wondering. And he refused to tell. He's like, well, I can tell you a range of some of them. I'm not going to say what the furthest one out is. And so I kind of just went off of that. Like we have a 32-inch disc, and we just try to get as far out as possible.
Yeah. And also the weapon itself, it's a lot of the weapons on Battlebots range in the 30 to 50 pound range. And so we're always trying to sort of push the limits and be as destructive as we can and as powerful as we can. So we really spent a lot of time optimizing the design, from the way we internally packed it to to save weight, to a lot of the types of materials and components we used, to make the design very, very sleek and very optimized for performance. And we'll talk a little bit about that in a bit. In general, though, a lot of people ask us how you get started with Battlebots. It's very, very hard to get started with Battlebots by just designing a BattleBot that's 250 pounds. Even before we came into season 3 of the show, for like the previous 2 years, we'd been thinking about how we were going to design Valkyrie, but we didn't quite have the knowledge or the skill set. And we spent most of those 2 years sort of building up that knowledge and that skill set. We competed in we built these smaller versions of Valkyrie that you can see here. And we also built a sort of trial run heavyweight robot for a competition in California called RoboGames. And it was basically just, it's called Boris Badenov, and it was a big box with, it kind of looked like a beetle, like a pincer. And it was just to get us familiar with what components we needed to use, what kinds of materials we could use, so that we knew, and so that we could go to a heavyweight competition and see what was out there, what kinds of things people were using. And then we could use that knowledge and apply it to the design of Valkyrie, so that we could actually make a successful design. So we knew, oh, these motors are the motors that a lot of these bot builders use, or these types of wheels are really good because you know, they don't pop, they don't deflate, things like that. You never really know what's going to go wrong until it goes wrong in robot fighting. So the easiest way to know what's going to go wrong is to try to make it go wrong, and that involves a lot of iteration and prototyping and figuring out how things scale. So even on the smaller weight classes with our 1 pound and 3 pound and 30 pound robots, it was all just like figuring out how do we build and optimize this system to work the way we imagine we want it to work. And I can just go and grab these 2 robots and show them to you. Just give me 1 second.
Go for it.
Yeah, and then with that, the first robot that we would have going out to RoboGames, that was back in, what, 2016?
2017.
Yeah, April
2017.
But the 2 things that I think were the main things I took away from it was having all engineers on a team. Everyone wants to do something, especially under pressure. And so that was sort of a way to learn how to set shifts for different people on the team and knowing when to step back, even if you're capable. That's something I did a lot, to just like not have too many chefs in the kitchen. And then also we used a mallet way too much, putting that robot back together. And then we learned, don't make a robot that takes a mallet to course every component back in if you have to take it apart. And so that's part of something we learned with Valkyrie, which has been a life-changing thing.
Yeah.
Part of that is not welding your frame together.
Yeah.
Screws are nice,
Growing
they can come out.
But yeah, these are some of the smaller robots that were sort of the initial inspiration for Valkyrie. This is foiled. It's a 1 pound weight class robot, and it was sort of the first original idea for what Valkyrie would look like. So the first time I competed with this, I ended up placing first in the competition, which was here at Artisans. So it's just kind of like, whoa, like this actually works. Like this idea could work. And then we made it a little bit bigger into foiled again, which is a 3 pound weight class. These are both standard weight classes in robot fighting. And they have competitions with these 2 sizes all over the country. The local ones are here in Massachusetts at Artisans Asylum. We also have competitions there's one we go to in Connecticut called Norwalk Havoc that happens every couple months. And then there's some bigger ones that sort of are that all the robot fighters from the Northeast go to in Pennsylvania that we also compete with. So I can pass these around if you want to feel for like the size and the scale of them.
Yeah. Beware, there might be a little bit of sharp edges, so like don't hurt yourself. But yeah, and yeah, I think that like it's important to like scale up. People do ask like, how do I get into robots? And I think that going with a smaller weight class is the easiest way to do it, not only for your bank account, but also just because a lot of physics does just scale, and that makes it a lot easier to like see when it works on a smaller scale where some of the behaviors are. If you start seeing them trending every size robot that you make of the same sort of design, you start to know you may have to be a little bit more wary of that with, say, a 250-pound one. Because obviously, once you say go on the cat of a 250 and spend thousands and thousands of dollars, when you finish it and it doesn't work, that wouldn't be great. And so we're able to like learn from the smaller ones before actually hitting go and building the larger one. Yeah.
All right. One of the other things about Valkyrie is that one of the things that we think makes us kind of competitive as a team is always keeping Valkyrie cutting edge. In terms of the Battlebots playing field, there's a lot of really like old builders, veterans that have been around for a while that competed. Battlebots has been around for 20 years now, and originally aired on Comedy Central. And a lot of the robots that are currently in the playing field are almost the same or very similarly very similar to built by the same people to robots that competed in that original era with a couple upgrades. And so you have this group of veterans that have been doing this for a long time, but some of the technologies they're using to run the robots are pretty outdated. And then you also have this influx of these new engineers and newcomers in the field like us that bring all these new ideas to the table. So we always try to keep Valkyrie very competitive and very high tech, because we know that that can give us an edge over a lot of the other the playing field in the competition. Some of the ways we do that is with modern design and manufacturing technologies, looking at what kind of technologies and software packages are available in industry and trying to use that to our advantage for the bot. So one of those things is we use a lot of metal 3D printing to build Valkyrie. In fact, on the robot itself, there are 55 3D printed parts that are on Valkyrie when it's fighting. And over the course of this build season alone, we 3D printed over 250 parts just to validate designs, test things, prototype things. You see in the top left in this slide over here, this is a sprocket, the sprocket that drives our weapon. And what we did is we 3D printed these soft jaws to hold the sprocket in our CNC machine, so that we could machine out that spline, that hole in the sprocket precisely to get it to work. And there's a lot of other ways that we've used technologies like 3D printing to improve the robot. Other ways include, prototyping. The first full prototype of Valkyrie we made out of 3D printed components and laser cut plywood or laser cut particle board. And we did that because what we wanted to do was, instead of just ordering all the materials and starting to make all the parts, we wanted to check that everything would fit together and everything would work well together. So we laser cut the entire thing out of wood and 3D printed all the components inside to make sure that we could actually build the robot how we expected to build it and sort of do a test run with it before we would make it out of the final materials.
The thing that also, by having it have this pretty sleek angle and stuff, is you do have a lot of annoying geometries to pay attention to, and if things don't just line up right, you're going to end up with an uneven nose on the front or something. So it was a really good way to kind of check for that. But yeah, so that actually is all made of 3D printed parts and wood. We paint it to look exactly like the real thing. But this was seriously, we know what we're doing in our application of we built the fake version to show exactly what we'd do if we said, yes, go, build the real one, spend however much we did. Mm-hmm. And yeah, I think that kind of was what helped us really be to the top of the stack for the applications for season 3. Mm-hmm. Yeah.
Brooks, do you want to talk a bit about the weapon design?
Yeah. You want to go back one slide?
Yeah, there we go.
So we have 3 blades, which we'll talk about more in a minute. But one of our designs, this is again on the cutting edge technology end of things. We wanted to optimize a blade as much as possible using finite element analysis in computer modeling software. So rather than just going in and saying, we think this is what how the blade should be shaped, we think this is where the spokes of the blade should be, we actually went in and started with a solid disk of metal, set up the software such that we said, okay, these parts are fixed, this is where the loads are, hit go and looked at where the stress concentrations were within that basically giant metal disk in software. Took that and then iteratively went through and said, okay, if this area is weaker, we can thin this out, remove this section here, and sort of push material generally towards the outside. So you'll notice that there's a couple large chunks on the outside there, and then much thinner sections in the middle. So this shape looks organic because it was sort of organically created by just iteratively going through and saying, if this is the load and this is the shape, where can we remove material, where do we need more material, and basically massaging the blade down to 65 pounds and then reasonably optimized for moment of inertia, which has I'm going to get a little bit mathy here, it has a radius squared term in it, so basically every inch you can move weight out gives you basically a 4x, every 2 inches you can move something out gives you a 4x benefit. So you really, really want all the weight to be on the outside edge, if possible.
Yeah, and that means when you're watching one of our fights, you'll notice that once our weapon's up to speed, it very rarely slows down unless something goes wrong.
Yeah,
And
we don't stop spinning.
That's because of that. So once the weapon's up to speed, we will just tear through anything. And that's one of the ways that we can make Valkyrie so powerful. A lot of horizontal spinners at Battlebots are bar spinners because bars are easy to make, but we wanted something that would be powerful and that would be very, very hard to stop, and that's what we did.
Yep. And yeah, the blade's made of abrasion-resistant steel. We actually order from a supplier in central Massachusetts that mainly does snow plows, material for rock crushers, stuff like that. So it's high-definition plasma is how it's cut out to be that shape.
Yeah. Yeah, you want to talk about this part?
Well, I mentioned with the mallets and hammers coercing shapes of frames to work well, we didn't want to do that again after being at RoboGames and being stressed out. So we ended up going with NASCAR style. We can tear a robot completely apart, every single part in its own pile in less than half an hour. We can build it up in about that same amount of time, maybe slightly more to just double check and Loctite everything. But we make it so right here you can actually see this is most of like a drive pod, well, two sides of the drive pod, but we can actually pull the whole drive pod out. So if like a motor goes or something, we can build up another one and just drop it in. And that makes it so if we do have short times in between fights, especially if we do get further along in the competition, that time is really valuable.
Yeah. As you can see with the robot, the entire thing is held together with bolts. There are other teams that maybe weld their entire frame, but that means if something gets hit, if something breaks, then you have to spend a lot of time repairing that. With our design, you can just take off a couple of bolts, put in a new component, and have Valkyrie ready to go. So it's very much like NASCAR style, where every time we get back from a fight, it's kind of like a pit stop where we really quickly replace anything that's broken. So we have 6 of these style of frame rails that make up the internal structure of the robot, and this is basically what holds everything together with base plates and all of our armor panels surrounding that. So if one of these goes, we can just take all the bolts off that hold this on, and then slap the new one in, and fix that problem. And it makes it really easy to debug and to sort of figure out what's wrong, because we can just take the entire robot apart and really dig into the details of what went wrong and fix it, or just swap in a new component really easily.
And one of the benefits Valkyrie has is modular armor. So while everything does look sweet and like black and silver, what the material is does vary depending on who we're going against. We have a mix of aluminum, titanium, and steel. We mostly run titanium and steel. Oh, right, there was a slide for that. And then on top of that, we actually have extra armor to like either turtle mode or just like pay attention to certain areas. Like if we're gonna go against a grabber or a hammer, we're going to put an extra top panel on top with some vibration dampers to make it so when we get hit, we're not going to have that go straight through the robot or shake out all the electronics and maybe have a failure there.
How many sets of armor do we actually have at this point? Like
A lot.
5 or 6?
Too many.
I would say 5 or 6. Yeah, and it's all just like being able to be prepared. For me, this was maybe my fault. We have a whole lot of armor just for that modularity and for spares as well. We want to be ready to make the robot as good as new when we come into when we end one fight and go into the next one. We want a new, fresh robot, and it's really easy to do that with a lot of spare parts. But also just in general, having that adaptability. The robot always has to be 250 pounds. So if you have an entire robot frame that you've welded together, for example, out of steel, you wouldn't be able to optimize that frame to protect for hits against the top or the sides. You'd have to kind of have an even distribution all around to protect from anything. And so instead of protecting from any hit anywhere on the robot, what we do is we configure the armor design to protect in very specific locations depending upon who our opponent is, so that the armor configuration is optimized for whoever we're fighting. So this armor configuration, this spreadsheet that we use up here, this was actually configured for, this moment it's configured for the most recent fight we had on TV, which was against a robot called Ragnarok, which was an axe bot. So we knew we wanted to protect the top of the robot And that's why you can see here we have our top shock-mounted armor that we've put on, and we have steel front panels just in case they nick us in the front trying to miss a top panel or something like that. So this is something that we feel is very unique to our team and our robot, is not just having weapons that we can swap out depending upon our opponent, but really adapting our armor to whoever we're fighting to get that advantage.
Theoretically, couldn't you add a 1-pound mini bot to that because you're still under the 250-pound limit?
That's true.
Technically.
Yeah. So for us, every pound counts, right? Every little bit where we can add material to protect ourselves could make a difference between success and failure. Whether that's another bolt to hold something down or a slightly heavier armor panel, it means that we are better equipped to defend against our opponents than we would be without it. So we really sort of value our defensive strategy because we want to be able to stay functional for as long as we can during a fight.
And in that summation of like what was there, I think we didn't actually weigh out all of the bolts of like how many would weigh what for it. So we actually have a couple times where we put it all together, every single bolt, and then we weigh it and we're like 0.2 pounds over or 0.3 pounds over. And production does care, and you have to take the weight back out. So we have to start strategically taking bolts back out. And so that's actually why, like in that one, like we actually wouldn't actually have the extra weight to play with mini bots, though it is super fun.
Yeah, exactly.
Yeah, weapons.
You wanna
I can talk about weapons.
Yeah.
Sure. So these, the 3 blades you see up here are what we fielded in Season 3, which was 2 years ago now. So left to right, we have Dr. Teeth, Spirit of Boston, and Sonic, or some variation on that. Gotta go fast. So the 3 blades actually all have very different purposes, but they all weigh exactly 65 pounds, plus or minus a half pound, and are 32 inches in diameter. So they're all totally modular. We can swap them in regardless of armor configuration or anything like that. So Dr. Teeth is the one I was talking about earlier. That's our pseudo-mathematically optimized blade. That blade is really good for medium hits, things with wedges. Basically, anytime we want to hit hard and keep spinning, we go with Dr. Teeth. In the center, Spirit of Boston is, as you can see, it's a more traditional bar spinner. We do this against things where we really just want a lot of surface on surface contact, like that, because it's just a big straight bar. It's also going to spin up a lot faster because it has that smaller moment of inertia. So we need to put less energy into it to get it going fast. So if we think we're going to get box rushed or something like that, we would typically go with a bar spinner. And then Sonic on the right. This one's really good if we want to get a lot of very small hits in on a robot. And we want the blade to just never stop spinning for any reason, even if we're not going to get big hits in the process. So if there's a robot that has very soft exposed wheels, a weapon we think we can just sort of cut away rather than having to get off in one big swing, we'll go with Sonic, because it's going to get hit after hit after hit after hit without slowing down.
Yeah, so it's kind of more like a saw blade where it will progressively cut into things rather than like a baseball bat, which just hits things really hard. So I would say like Dr. Teeth is kind of in the middle of the 2 extremes of Sonic and the Spirit of Boston. Yeah.
And yeah, next we already
Go ahead.
talked about that.
Yeah.
So 2019 upgrades. We had a couple of things. We were actually really happy that one of our friends, like Jonathan, part of Huge, he made a comment of like, man, you know, the idea of going home after a robot season with your whole robot basically still together. I was like, tell me about it. Yeah. Because that's what happened. Like last year, we didn't have that much done to us. Like we had some failures, but a lot of it was like our own bugs. And so we kind of just were obsessive, because we're engineers, on what we wanted to change. Like whatever thing we weren't happy with, or where we were lucky, we saw something that might have gone wrong, and then we were lucky in our matchups or whatever. And so we were able to come up with a couple things. Like I guess.
Yeah. One thing to note before that is like we came home with all of our spares, so it wouldn't make sense to redesign the robot because then we have to throw all of that out. Mm-hmm. In one thing we didn't mention, in 2018 we had a 4-2 record. We went 3-2 during sort of the main season, and then we had one grudge match, and so we were just short of the top 16. We were in a rumble with, like, even when we were in a rumble with 5 other robots in the box at the same time, the damage that we took was like, it was enough to, we lost our weapon during that rumble, but it was like, altogether, the robot still worked at the end of everything, which was baffling to me.
And that rumble, we were the only rookie competitor, not rookie robot, because there was also Duck. But yeah, that was another thing that stood out. Like, we were able to like stand with those guys and actually end up coming out of there a little bit better than some of the older guys.
Yeah, but also last year, every fight, something went wrong with our weapon. Actually, every fight except for one, which was against Red Devil. If you haven't watched last season, there was a fight last year where there was another robot that had these, it's kind of built in modules, and we hit the robot in such a way that the robot split into 2 halves, and both halves kept moving at the same time, and it was definitely one of the more exciting fights of the season. But almost every fight apart from that one, we had a weapon issue where our chain broke that drove our weapon, or in some cases our weapon broke. During our fight with Lockjaw, do you want to describe what happened?
Well, the next picture, I think, also, right? Yeah, just kidding, there. Donald broke the Spirit of Boston. Lockjaw, the captain, Donald, he's from San Diego, but basically the Spirit of Boston broke because we used an S7 blade, bar, and then welded that ring to it. In the process of welding it, we changed the material properties around those contact points and made it so when we sent it off to heat treat, it made the area brittle. This is where like material science is kind of great with this, because like if you did this in like a regular application for like a robot, like say Boston Dynamics or something, you probably wouldn't see it break because it's not going to get bashed around by another robot. So it's sort of a extreme type of failure.
And you can see.
Yeah, I would say, and if you know material science at all, the way that the fracture point is on it does show that is just like completely a like material failure of how it broke.
Yeah.
It's actually a really beautiful, if you, it's a little bit too heavy to pass around, but if you want to come up and look at it later.
Just a little.
It's actually a very beautiful, perfect textbook example of what brittle failure looks like in a metal. It's the inside of that break is incredibly smooth.
Yeah. But yeah, it's basically, as I said earlier, a lot of what Battlebots is and how you make a good Battlebot is all about like failing early and failing often, figuring out what went wrong, why it went wrong, and how to improve it for the next time you compete.
And so this year what we end up doing is, okay, no more playing welding, see if it works with heat treat. Let's just start with harder material. Hey, abrasion-resistant steel works great for the other ones. Why not make that for the bar spinner option as well? So we decided to go with more of a bow tie style bar, because this actually ends up having a higher moment of inertia than just a bar alone, while still staying at that 65 pounds. And the way that having it have a curve like that, it's going to be able to provide a little bit more bite. And by having a higher moment of inertia, it won't slow down as fast, because we did see that the bar spinner does slow down relatively quickly compared to our blades.
Yeah. Also, just a note about different materials. S7, which is what that bar is made out of, is a tool steel. It's very brittle, but very hard. So it can bite things really easily. It can cut into things really easily. But in the long run, it can snap pretty easily. So it's because of that hit, it snapped. AR500, on the other hand, is a very tough material. So instead of snapping, it's more likely to deform or to flex. So it's kind of like the difference between like rubber and like and cheap plastic, except on a much higher strength scale. And so going with a AR500 weapon blade means that the material will deform instead of snap when we hit another robot.
And the only negative is that a lot of robots do use AR500 as their armor as well. So now you're playing hard against hard, and depending on how things are hitting and what like speeds or whatever that's dealing with, like whatever's behind it, will depend on who wins that fight of just like smashing two against each other.
Yeah.
So.
One of the other things that we wanted to improve, I was talking about the weapon performance a little bit earlier. So one of the main goals this year was reliability, making sure that once things were working, they stayed working for the entirety of the fight. So that's one of the major reasons why we upgraded our weapon system. We had a lot of failures last year. Just little things would go wrong, like our chain would break, or or what else would happen? Our weapon would cut its own sprocket off,
When we switched out the front armor, it was kind of a headache because of just having
Yeah.
this part floating.
yeah, a lot of reliability or a lot of maintenance issues where you can see in this photo on the left here, we have our old upper bearing block, which is one of the things that supports our weapon shaft. I'll actually go grab it.
Yeah, go ahead.
So what they alluded to earlier with the floating part was this bearing block here is actually half of the system that holds the weapon blade vertically in place.
Yeah, so that's this.
And this piece was actually supported entirely off the armor. So with what they were saying earlier about NASCAR-style repairs where everything can come off like that and go back on really quickly, that doesn't work as well. Like there were two panels on the front that we couldn't take off without the weapon blade just like canting to the side, which was not great when we were trying to do a fast repair because it's heavy and hard to move around. So for this year, we basically took that Alex basically took that piece, integrated it into the center two frame rails, and then that actually became one part and one assembly in the center there instead of this floating awkward piece. So it actually became a lot easier to swap out the front armor this year as compared to last year.
Yeah, and it made it the robot generally like with other upgrades to the weapon. So we had the bearing block. So this bearing block, instead of being floating, was actually attached to two other frame rails over here. So this is that upper bearing block. This is the shaft that we use to that the weapon attaches to. One of the other improvements was basically we have this clutch mechanism, and
Custom clutch.
it's sort of a custom clutch. It's one of the more ridiculous things we had to design when designing Valkyrie. What happens is when you hit something really hard with a robot weapon like ours, all of that shock and all of that energy goes right back into the motor that is driving the weapon bar. So what you want to do is have some sort of fail-safe or some sort of slip so that all that energy doesn't overload the motor with too much shock. So previously we had a clutch mechanism on our weapon side, and we moved it to the motor side for a little bit of more reliability and a little more protection. So this is just a demo of how that clutch mechanism works. We have these two white pieces here, which are effectively serve as friction pads, and we have a bolt here that squishes this sprocket that drives the weapon against the two friction pads. So depending upon how much we tighten this bolt, at a certain level of force, when we hit another robot, this will slip between the two clutch plates, whereas most of the time it will drive that weapon. That means we can easily safely protect our weapon motor from these big impacts and prevent our robot from pretty much destroying itself and destroying the motor. So there's a lot of ways that we kind of tuned this mechanism to work better for a robot than it did last year.
Yeah, basically you can think of it as like a flywheel. And when we had it on the weapon side, there also was a lot more surface area there. So that was another reason why we were having some issues there where it wouldn't spin enough if we had it too loose, or it would spin too reliable. And then, yeah, like you mentioned, having all the power backtrack into our motor, which did happen. And so moving that onto the motor side, there was a lot more freedom to be able to just let that just keep spinning and it not affect anything else in the system.
One other thing to note about the clutch and why it's so important is when the blade hits something and stops dead, the robot doesn't actually know that that's happened, and we're still dumping full power into the motor at that point.
300 amps.
Yeah, 300 amps, somewhere.
That's peak.
It's peak now? Oh, Jesus, I thought it was 200. So 300 amps at 90 volts, which I'll let you guys do the math, but that's a stupid amount of power. In Season 2, we actually liquefied the brush assembly in the motor. And I don't know if you've ever seen liquid aluminum splatter inside a thing where it's not supposed to be, but it's kind of freaky. So the other thing the clutch does is it prevents the motor from stalling, and that way that energy all becomes rotary motion instead of heat. Because if you put 3,000 amps at 90 volts into heat, you melt things that don't want to be melted.
Yep. One of the other major improvements we made this year was, again, just figuring out all the little ways in which we could optimize things, just so that we could get Valkyrie to be even more effective than last season. So again, on that sort of cutting edge theme that we stick to, we want to use modern technologies to design and manufacture our parts. One of those ways was using generative design. So basically, generative design in a nutshell is all about using, we used Autodesk Fusion 360's generative design program. And what you do to design your parts, in most 3D modeling programs like that we use to design the robot, the engineer goes in, thinks about how robust the part needs to be, maybe does some calculations, does some math to figure out how to design it. Generative design kind of takes the opposite approach, where you say, hey, I have this part. What I absolutely need on this part are these little green sections here. Those are critical to this part's success. And then you say, I know this part is going to get hit with this much force. So we know roughly how much force is applied to different elements of our robot, depending upon like how fast our weapon spins, for example. And what we can do is we can say, we have this part that needs to hold these two things together. We know that it can't go into these red areas. So this is our motor bracket. It holds. It's one of 4 brackets that holds our motor onto our frame. And so we can say, hey, we have this part. We have these loading conditions that we know the part's going to be hit with. We know we're going to make this part out of this material. Go. And then the 3D design software figures all of the rest out. So what we're able to do is we're able to make the perfectly optimized shape for these different components inside the robot. And now that allows us to save a whole lot of weight that we can then apply to other elements of the design, like the weapon and like the armor. And so all these little performance improvements really help us stay competitive and make our robot even more powerful than it has been in previous years. So this was sort of the input into designing this bracket. And then this is the output where we're able to have this perfectly optimized design that we metal 3D printed on a Mark-forged metal printer. And this is one of 4 clamps that sort of holds our weapon motor down. And it's just as strong as it needs to be for this application. So this is one of the neat features about Valkyrie, where we're always trying to improve the robot and save every little piece of weight on the inside of the robot so that we can apply that saved weight to the outside of the robot and make it even stronger.
And yeah, you can play with it after, so but basically, or feel passed around. But it kind of looks like bones. All of the stuff that generative design seems to spit out looks like bones, and it's really cool. And so that's kind of like generative design has become my new favorite obsession. I want to design everything with it because it's just really neat to see that it does lean everything out. One of our friends actually pointed out of like, oh, gee, look. How surprising how like skeletons, human structures they look similar to what this program spits out. Who would think after thousands and thousands and thousands of years of iteration, we figured out a more effective structure for the human body. But yeah, they're super cool. Like the metal 3D printing, being able to do generative design is like easily what our superpower, if there's another season, is going to be.
Yeah. One of the other big things was along that reliability track was doing an electronics overhaul. So we we had some issues with our electrical system last year, both our weapon system and our drive system, where sometimes things would kind of stop working and we wouldn't know why. So we kind of redid our electrical system, made it a little bit more efficient, smaller batteries, smaller motor controllers, better motors from a better supplier, and all to sort of make every little bit that we could more efficient. One of the things we actually realized when doing this was during this season, actually, in between the fight that just aired, our fight a couple weeks ago against Ragnarok, and our next fight, we realized why our drive motors were failing unexpectedly. This had been happening last season, and we thought it was just kind of because we had bad motors. But we actually realized what you'll notice is this is one of our drive motors, and this plate here is our base plate, and there's an immense amount of shock that gets imparted into our robot when we hit another robot really hard or when another robot hits us. And what was happening was this base plate, which is half an inch thick, was flexing and hitting the bottom of our motor when we took or delivered a really big hit during a fight. And what that meant was something on the inside the motor would always pop loose almost every single fight last year, and in our first fight this year, and destroy something inside of the motor. We didn't know why this was happening. We thought it was just we had bad motors, but we realized it was because of that flex in our system where this base plate was hitting here. So what we did during the show actually is we realized what was happening, and we were able to adapt on the fly. We brought 4 carbon fiber 3D printers to the filming this year, and so we were actually able to 3D print these improvements to our robot and also to everybody else's robots to make the robots perform even better. So we printed this little cradle that cradles the motor so that it prevents it from bumping into our frame anymore. The carbon fiber 3D printers, they reinforce parts with continuous strands of carbon fiber. So it means these parts are just as strong as aluminum but much lighter, and they print things really fast. So we discovered this problem, we printed a solution for it the same day and installed it on the robot, and that meant every single fight after our first fight, Valkyrie was higher performing than in that first fight, just because we were able to improve on the fly. And we were able to help a lot of other teams solve these types of challenges as well, with the Mark Forged carbon fiber 3D printers to allow for that, and to really keep everyone's robots performing even better than they were when they started.
How many parts did we end up actually printing for other teams this year?
We printed 161 parts for, there were 67 teams there this year, and we printed 161 parts for over 30 of the teams there. And that's all these different types of little fixes where you need this really strong thing to hold this part in a particular way, or you realized there was a flaw in your design and you needed to make a revision on that part, but needed it to be lighter weight or needed it to be done the next day because you had to fight the next day or something like that. So we were able to really quickly turn around new solutions to help both our team and all the other teams here.
So show experience is kind of open-ended. It can be either question-based or we can kind of just list off stuff. I was thinking it makes sense of just sort of listing like a couple, without spoilers, what you liked the most, what you didn't like the most, and what you were not expecting. I want to go last because I was technically at season 2, so I got to learn the behind the scenes before actually running a team.
Yeah. I'll go first, I guess. So the show in general, how the show works is the episodes are released every Friday over the course of this summer, and that's how it worked last year. But all the filming actually happens over the course of 2 weeks in the beginning of April. So around late January, early February was when we found out Battlebots was returning. And from then until the end of March, we were just non-stop building. And then we have a 2-week break where we've shipped the robot off and it's on its way to California. And then we are basically in this big warehouse where they set up all the pits, they set up the arena, they set up the stands. It's all in this one big warehouse in LA, and that's where all of the filming happens, and you have to do everything in 2 weeks. So I think what was it, favorite thing, least favorite thing?
Yeah, and then what you weren't expecting.
What I wasn't expecting. So I think my favorite thing is honestly the community. In the box, basically how I describe it is when we're in the box, we're enemies, but when we're out of the box, we're friends. And everyone there just loves building robots, right? Or else they wouldn't be on the show. And so it's really, really great to interact with all these other builders that have had their own journey of designing these giant death machines. And what that ends up meaning is that we're all looking out for each other, we're all supporting each other, and we all just want to have a good time and want to put on a good show. So there are times when we've helped other teams that we've fought against or that we know we're going to fight against, and it's all just good camaraderie because we all just, I don't know, it's all just fun robot building. We Hypershock in our first fight, we're really close with them, and they helped us out, we helped them out many times, and so it's just really nice to see that cooperation between different teams where we're all just kind of trying to support each other, trying to help each other make our robots better, because that's the fun of it. That's how we learn, that's how our robots grow, that's how we get better robots, that's how we get better battles, that's how we get Battlebots to keep coming back every year. My least favorite thing was when you're basically just in this warehouse for 2 weeks, and there's this hotel where all of the builders stay at the same hotel, and so you're just with the same 200 people for 2 weeks, and sometimes you've just fought against them, so there might be some tension or something like that, and so it's just we had a lot of late nights where we kind of forgot, or we went to dinner really late or something like that, and you're thinking about robots all the time. You're always around these robot people, and you're always talking about these ideas. So it's kind of hard sometimes to find a break from that, because there's always pressure to fix your robot for the next day and make sure that you're everything's set and everything's ready. And so having a little bit of time to relax is hard to come by. The most unexpected thing, this is a kind of silly one. We had a bit of a nightmare when we were packing our robot up. We put it in this big crate that was 8 feet tall, filled with all of our robot parts and all of our spare parts and everything. The crate was 8 feet tall. The morning they were supposed to come pick the robot up and put it in the truck, we realized that the doors of the truck were 7.5 feet tall.
Yeah, Robot sent a picture of their crate being loaded, and it was only a 6 foot tall crate, and there's definitely less than a foot till the top of the gate.
To be clear, we told them we had an 8-foot crate.
I called.
Yeah.
I was like,
So-
what do you have for dimensions? And they confirmed 8 feet.
So 2 hours before they were supposed to pick up the robot in the crate, we had an 8 foot tall crate and a 7 foot tall door. And so we had to rush to Artisans Asylum where the crate was going to get picked up, and then saw the top of the crate off, take the top of the crate off, saw the panels of the sides down, and put the top of the crate back on, all within 2 hours. So we were kind of standing there with a circular saw going around the crate trying to cut it. And in some point there, I lost my glasses, and I had no idea where they were. And so for 2 weeks, I was just I thought maybe I didn't bring my glasses, maybe they're at Artisans somewhere, I really don't know. And I'd just gotten these new pair of glasses, and I had no idea where they could be. And then the first day we got to Battlebots, we're unpacking the crate, and I find my glasses just sitting there covered in sawdust between all of these robot parts. And it was quite a relief, but it was very I was very relieved after that moment, because I'd just gotten these new glasses, and they're titanium, so they're supposed to be super impact resistant and lightweight. So I was really excited to get them, and then I lost them, and I had no idea where they were, and then they showed up inside our Battlebots crate. I don't exactly know when they got inside there, but it happened at some point.
Yeah. How about you?
So my favorite thing about Battlebots, honestly, is exactly what Alex said. The community is far and away the best part of the show. Everyone is incredible. Every single person at Battlebots is very invested in the sport of Battlebots, but also in having good fights. So there's no oh, we're gonna be sneaky or try to make this team's robot not work. It's if your opponent's robot is broken, you're very invested in helping them fix it, because the whole point of being there is to have good fights. and that doesn't happen if your opponent's robot doesn't work. But just in the interest of sharing more, rather than saying that's my favorite thing, I think my second favorite thing about Battlebots is probably seeing how all of these people from all around the U.S. and all around the world actually took this same problem of make something that's really good at smashing other things that are really good at smashing things, and how many different directions that they took that. Like, there's an incredible diversity of like designs, even within like the same weapon type. There's an incredible diversity of like how people actually solved that problem, and everyone has really cool reasons for why they did what they did, and everyone can just going around and like talking to people about why they made their decisions, like how they ended up with the robot they ended up with. That's a really cool thing to be able to share with all of these people from all over the world. Least favorite thing, definitely the food. The food is very bad. Battlebots is catered.
Only lunch.
Only lunch is catered. Not good. Not good. And I think my most unexpected thing actually kind of goes against what Alex was saying. His least favorite thing was it was a lot more relaxed than I expected. Like there were definitely moments of like abject panic where you're like, okay, we have 30 minutes before we have to be in the box, and the robot is not put together, and you're just sprinting like for a couple hours at a time. You're just going. But honestly, like coming from a first background, those competitions are 3 days utter mayhem with just no stopping. Like the people on the teams who are the most involved often like don't get lunch or have to have lunch brought to them. Partially because Battlebots is spread out over 16 days. There was a lot, actually felt like a lot more downtime than I was expecting fight to fight, because the fights in the normal season are like 3 days apart. So if you don't have any significant changes, you can go in, make those repairs, and then sort of not hang out, but like you have freedom to like make sure that your pit is clean and like make sure that all your tools still exist. And that's sort of just like nice housekeeping stuff. You actually can do it. And especially if you have, like we had a varying number of people at various points in the filming, but if you have like 7 people, I think is the most we had at any one time, there is actually free time to go around. You don't need 7 people running full tilt the whole time. And that was really nice.
And then what did you not expect, or was that the not expected?
That was the unexpected
Okay,
thing.
cool.
Yeah, my unexpected
Alright.
thing was breathing.
The good, well, like obviously the community is great. Everyone already said that. I think that if you are nice to production, they're nice to you, and I think that's nice because there's also some teams that are kind of jerks, and so then obviously then they didn't have as good of a time with production. So like, just be a good person and good happens back. So I like that, and also just there's a lot of interesting stories from the people on the crew side of things. Least favorite thing. Well, like the matchups, but that's just like a given. It's like really difficult with a show that has 67 robots. You have different tiers of what the robots can do, and also like, you know, there's some robots that would just get eaten alive if they were faced with like say Tombstone or Bite Force right off the bat, or like even us. And so like the way that they balance out who they put against people, and not just us, like I have friends on a lot of teams, and so watching their matchups and sometimes being frustrated with who they got matched up against, like that always sucks. And then of course, like, you know, everyone can grumble about judges' decisions and stuff, and we can too. And then thing I didn't expect the most, well, like I was part of season 2, part of a disqualified team, and I think that I think the surprise part was how no matter how many times you have like the sound effects and the blinking lights and the counting down 3, 2, 1, it never gets easy, and you feel like you're about to like faint. Like you're just like, and I don't even drive. Like that's part of why I wouldn't even want to drive. Like no thanks. Like it's so stressful. There's nothing else I can think of in my life that I've done that feels that nerve-wracking, and I didn't think I would get that scared or nervous about it. So yeah.
Yeah, in the box, like on the show, they make everything before the fight seem kind of quick, where there's like red team ready and the red team presses the button and blue team ready and the blue team presses the button, and then there's like a boo sound, and then the timer goes like beep, 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 burn, and then like the robots fight. But actually on the show, the timing between those is much more spaced out. So like you both say you're ready, and then you wait a minute or 3 minutes, and then like the big cool sound happens, and everyone's like, when's the match gonna start? And you might be standing there for a minute like, we're gonna be ready to go. We're ready to go at any time. And so you have to keep that tension and keep that like pressure up. And then like finally the lights go down and you're like, okay, go, 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 get the weapon spun up. So it's really, there are some times with, like we'd learn our matchup and I'd be like so stressed out for like the entire day before. Yeah.
Yep. Yeah, well, you know, almost like the heat was way worse last year, and it's part of why we decided to go jackets over one-piece suit things.
Yeah.
Because there was like
LA
a
is warm.
90-something day last year that like all of us were kind of dying, and yeah, like Alex like almost fainted at one point, and so like, yeah, it's high stress, definitely. And then yeah, I don't know if there's like do we have something for mid-season improvements at all? I don't know. We'll go later. Whatever.
Yeah.
Anyways.
Right. We wanted to give a shout out to our sponsors. Mark Fords, I mentioned them. They are a high-strength 3D printing company, so we printed a lot of parts on the robot with Mark Fords printers. TE Connectivity, they gave us a lot of connectors, very robust, rugged connectors, which meant we pretty much never had an electrical failure this season. Autodesk Fusion 360, we used their software package to design a lot of the robot this year. Datto, they're a software security company that sponsored us this year. General Catalyst, one of the local startup incubator, local
investor.
Local investors. Equal Zero Designs provided us with a lot of electrical components or motor controllers this year. Andy Mark is, if you're familiar with First Robotics, they're a supplier and a manufacturer for a lot of First Robotics components, so they sponsored us this year. And as we said, we are very involved in the First Robotics community. We give talks at a lot of First Robotics events in schools in this past year. And also Artisans Asylum. We couldn't have done it without having the resources here for our space.
Yeah, being accessible in here has been very useful. Like Somerville is obviously up and coming tech, but we've been here obviously for a couple years, and being all engineers, we have jobs kind of centralized in Boston, so not having to go out to like Malden or Worcester, somewhere where warehouse space is a little bit more affordable, and having the space here and stuff has been just like, yeah, without makerspace, Valkyrie would not exist.
Yeah.
And yeah, I guess like we have a bunch of questions. It's like just after 8, so we have a bit of time, like about a half hour to answer all of the things within reason. Can't give any spoilers still. I can vaguely say we will fight after Shark Week. I know like it's in August. I'm not allowed to say the date, but it's a good one. And yeah.
So we have somebody here named Scott Dumas who says, Valkyrie, you are my second favorite robot after Hugh.
Come on, Jonathan, you're not even here right now. Like, so the question is if we're, like we mentioned, the new school versus old school robots, and if that sort of is a NASCAR thing. I think, like, for us, it's sort of like they've had years of experience of trials. Like, our robots are too dangerous to really do much testing outside of the box. So, like, that's where we saw that a lot of these teams had the upper hand, was that they've actually been able to do iterative testing, and we have, well, we designed it to as best as we can, and now we have to let it go behind protective glass that won't tear things apart or cause a lot of damage. And the other side of like is just realizing that we are a new generation of engineers. We do have a couple decades younger than what they have, and I think that just the way that technologies have evolved for the way that manufacturing and design is done, I see it as a huge advantage to like pick up on that as quick as possible. Like actually Duck, Hal totally adapts to like newer technologies also, and you can see like his robots don't die.
Yeah.
Duck is also a beautiful robot internally.
Oh my gosh.
Yeah.
Everything
So
Hal
pretty.
designs is gorgeous. Yeah.
Yeah, I feel like it does depend on the builder, but in general, if you look at the old Battlebots, especially on the original show, they don't do nearly as much damage as these ones do. And so you really have to think more about how you're going to swap things out in your robot. And so we were able to bring this, when we designed a new robot, we were able to bring this new thing to the table.
And there's, oh yeah.
Yeah, we wanted to fix it quickly.
And then similarly, I think that some of the newer teams, there are like, not personally like me specific, but there are some newer teams like Huge that were fans of the show growing up. And so like Jonathan does have like almost an obsessive memory of like every robot. He's able to like list off failures, positives, how changes happened, when they happened, all that. And so he's able to sort of like, Huge is a very unique design. If you haven't seen it, it's a giant set of wheels with a bar spinner in the middle, and it's so high up, its chassis is so high up, no robot can really reach it, which is the appeal, because now he can kind of like skirt around everyone and hover over them to destroy them. And that was his take on looking at the old show, and so it's sort of without the old design robots, he wouldn't have been able to think of the new design, which I know that he did copy the Big Wheels idea from Gabriel, which is a Robot Wars robot, but there's a lot of special sauce he's put into that I think he's on his own.
Yeah. Oh, also, last thing on the modularity thing was, like, because we're able to build this kind of NASCAR style where we have all of our parts and we can kind of assemble the robot real quickly, during the event there are times when we build 2 robots because we know we have fights back to back. You can't really do that when you have like just a single frame. With some of the older show, you're not taking as much damage, so it's easier to just have your one robot and fix it if something comes up. But because there's more damage here, if we fight and then something happens, we need to be ready to fight again, especially back to back. So in the Desperado tournament last year, we built up both of our robots because we knew if we won a match but took a lot of damage, we could just throw in the next one because that was filmed all in the same day.
Have you, by the way, you're my second favorite robot after Team Witch Doctor. Have you met them, by the way?
The comment was we're also a second favorite robot, and that his favorite is Witch Doctor, and was asking if we have met the Witch Doctor team. And yeah, we mentored the community. All of us are pretty good friends. Like I do talk to like Andrea and Mike semi-regularly. Mike actually was the one to inform me that apparently the internet had fun making me a meme. But yeah, and you could.
Yeah, I actually met Andrea and Mike at a different robotics competition in Utah just before season 2. Yeah, it was before season 3. Yeah, it was before season 3. And one of the things that's interesting is like some of these people have been like around Battlebots their entire life. Mike and Andrea, the Witch Doctor team, they've been building fighting robots since they were in high school, which is crazy. I became a fan of Battlebots in this sort of era of the show with season 1 and season 2. That's like what got me hooked. And so when I met them for the first time, it's like you're meeting a TV star, you're meeting a celebrity. You're like, oh my gosh, like you were on TV and now you're here and we're fighting together and that's crazy. And that's a lot of my, that was sort of my internal monologue to a lot of the builders that I met when I wasn't on the show yet. And then I met them and I was like, oh my gosh, you're famous, you're a celebrity, you're this crazy, like this is so cool. And then like once you're on the show and you become friends with them, you realize like, oh, these are all just people like me. Like we all love building robots, we're all into this stuff. Like we all just kind of got here because we love making things. And that's something that was really cool about meeting a lot of these builders and a lot of these teams is we're all just really interested in making these destructive robots.
And one last thing about Witch Doctor is that like Jonathan and I talk about this because we're good friends, is what would Witch Doctor do is something we regularly kind of default on, of just like we're a team, a lot of teams don't do any sort of outreach, like even something like this. We do a lot of more personal stuff like going to a high school, talking about the robot, whatever, going out of our way. And Witch Doctor really sort of sets like the bar on that. They do so much engagement. They help with like robot building classes and all this stuff. And so I try to at least take a note from them of how I go forward with stuff.
Yeah,
so.
A lot of respect for that team.
So you guys mentioned the importance of meeting the weight class, and they can get down to several fractions of a pound there. What's your process on how you distribute the weight? I mean, are you starting with the motor on the innards and working outward, or do you guys just always keep blade in play?
I was about to start talking about it. But I'll just say that the only thing we did have, actually, it's in the appendix, is a picture of us piling components with cardboard around it. Is we did start with like, okay, we know we need 2 drive motors. We know we need a motor for the weapon, at least 1. And so we did start pile an arrangement of what we thought we could get it to look like. And we did have the wheels actually. Fred, our driver who's not here, he's off racing go-karts with the same wheel assemblies as what we use in Valkyrie. And so, yeah, you can talk more about it.
Yeah, it's kind of just like at the point where we started designing Valkyrie, we knew like these are the motors we want to go with. They weigh this much. So we start with all the things that we absolutely need. So weapon motor right there, drive motor, wheels. One of the kind of guiding principles that a lot of people state is you want roughly a third of your weight for weapon, a third of your weight for armor, and a third of your weight for electronics and drive. And that's kind of where we started. Usually you design for that and then you realize that you underestimated how much weight the armor and the electronics will take up, so then you make your weapon a little bit smaller. But generally, yeah, it's all just kind of like you start from what you know you absolutely need, and then you figure out, do you want an offensive or a defensive strategy? So do you want to go with a bigger weapon and sacrifice some of your armor and your defense? Do you want to go with a more powerful drivetrain? So it's all a compromise. It's all these like scales that you have to tip. Do you want a more powerful drivetrain so you can push other robots around? If you do that, you might need a smaller weapon or less armor or something like that. So it's all this balancing act, and it's really up to each builder. As Brooks was saying earlier, everyone has their own unique design because they've all balanced the scales differently. Tombstone, mostly weapon, not much armor. Huge, mostly plastic, and so that it's huge.
Yeah. His weapon bars, they vary by what he puts in, but they're way less weight. Like, they're easy to casually carry around. That takes a bit of lifting prep before you get used to it.
Yeah, and for us, it was really about how do we stay adaptable. So we want the weapon be as powerful as is reasonable, and then
Or unreasonable.
And then how do we change the armor around? So instead of having a fixed weight for armor, we have a weight that we can move around what we need to get the reinforcement we need.
One of the ideas, which you'll see whether or not we have to use it, with the 50-pound blade versus the 65, was because we wanted to have the option of turtle mode, which is basically like armor up like crazy because we're going to go against someone that punches hard like Tombstone or Bite Force or something. And so that was because, like, from the eye, most people can't eyeball an 1/8 of an inch difference in thickness of a weapon. Gigabyte did, but a lot of people can't. So they'll think that we're set up the same and magically had enough weight for all the extra armor, and we don't really. It's just like we're gonna have like smaller bites.
Well, don't tell them that.
Well, we'll see. I mean, we could be amazing.
Yeah.
The stealth bomber shape is a cool one, but you're driving around 250 pounds with 2 wheels in the back and resting on a rotating mass in the front. That seems hard to drive. Did you consider other options, or how did that fare?
I can talk. Yeah. So that was one of the biggest design conversations, I would say, that we had going into season 3, was where forward to backward do we actually put the wheels, and the center of gravity of the robot, and how that affects the driving dynamics. Valkyrie, I think, has some of the weirdest driving dynamics of any robot I've seen at Battlebots. It's floaty. Which
It's
is
jet
not,
ski.
It's jet ski. So I'm going to dig down a little bit and then sort of get back up to the question. So the center of gravity of Valkyrie is very close to the front of the blade, or like very close to the blade axle. It's about an inch. It's like 1 to 2 inches behind it, which you can't really see the robot, but that's very, very close to the front, which means that when we're up to speed, almost all the time, but especially when we're up to speed, almost all of the actual friction that we're applying to getting applied to us from the ground is on the blade, not on the wheels. So if you watch Valkyrie turn when we're spun up to speed, the frame of the robot actually rotates around the blade. rather than the other way around. And initially, we were pretty concerned about this. Perfect. Yeah, so in that top view there, the black part of the blade will actually stay stationary, and the black part will spin around it when we turn, which originally we were actually a little bit concerned about because we were thinking, okay, we're not going to have very good maneuverability, our wheels aren't going to stick to the ground very well, which is true. We are not fast at all. But this actually gives us a really big maneuvering advantage because a lot of these robots with the very heavy weapons, if you watch them turn, they actually either turn slowly or if they're turning around think like Minotaur. When you see Minotaur turn, it pops a wheelie on one side because of the gyroscopic forces in their blade. Since we're turning around our blade, the gyroscopic forces are actually totally negated, or not. They just don't come into play. So we can actually turn very quickly in any situation, which is very, very nice. Yeah. And also because then when the blade is spinning, we have this dynamic contact on the ground, so we actually have a pretty low coefficient of friction to the battle box. What that actually lets us do is sort of slide sideways by varying the weapon speed, driving a little bit at a weird angle, but we can pretty much drift around.
It also allows us to get our frame out of the way of other robots easily, so that if we're driving and approaching another robot and they change tactics and try to get us from the side, we can just swing our wheels out of the way so that our weapon is always pointed at them. That's kind of our generic driving strategy, is keep the pointy end pointed at the other robot, and it's easy when we can turn so quickly.
And when we were first looking at, rather than just having, so that bottom piece is actually a piece of UHMW and it is a consumable. We switch it out every fight because obviously it wears down just from driving around the box. And we did consider other options like ball caster or whatever, but we knew that if it was going to get banged around or just the amount of force that was going to be there and the gunk in the box and how uneven it is and everything, that was going to bind up really quickly. So we just figured plastic's cheap enough, just flip through them. We have different thickness ones and everything. They're just turned down to just have a point, and that seems to be, for now, what we've found to be the best option.
Yeah. Also, because the point under the weapon is spinning with the weapon, it means that basically what we learned, and this is something we learned from the smaller weight classes from lots of fights, is that if we lose any two of our motion, any two of the three things that are spinning, so either wheel or the weapon, we can always still move. Because if we lose a wheel, for example, we can still drive on the weapon and one wheel because the weapon spinning against the ground provides some amount of motion that we can control to some extent.
The box isn't flat.
Yeah.
So we can pretty much drift downhill, and it looks like controlled motion sometimes.
Yeah.
The secret behind our 30-pound robot, Spirit, which is basically the same thing as this, is that the wheels have never worked, and the only two fights that we didn't lose very quickly were ones where we actually just took the drive chains off and used the weapon to drive, and it went okay.
Yeah. And with my 1-pound robot, I've won fights after having lost both wheels, just because of that and being able to ricochet around. The other thing is, are the small robots still around?
They made it back to the
where
table.
are they? Okay. On the topic of wheel placement, if we get flipped upside down, the wheels are still set behind the weapon. So we can actually, using the gyroscopic force from the weapon spinning, we can self-right by sort of turning back over on our wheelbase. But also we could fight upside down if we wanted to, which happened in our Hypershock fight. So it gives us a little, having the wheels back. Well, one of the design decisions was we had the wheels back so that we could do that, but the weapon's also exposed in the back. So in a couple fights our opponents have thought, oh, their back is turned to us, we can go get them. And then they get hit because our weapon blade still sticks out in the back.
So hi everyone, we're nearing 8:30 and we have to kind of take perhaps one more question. Before I do that, I just want to tell you that I see a lot of children here. We do have a class that is a parent-child class to build a dragon robot. So if you're interested in that, maybe do that, which is awesome. And aside from that, I think one more question.
One more question
yeah?
for this, and then also
All right.
we'll be around for answering questions.
And thank you so much, WGBH, for
Yes.
live streaming. We are
Yeah,
so grateful.
thank you.
Yeah, thank
Yes, absolutely.
you. Yeah. Say it again.
How did you choose the theme Valkyrie?
How do we choose the name Valkyrie? Well, I think that, us three are the ones that went Wikipedia tunneling. So we looked at it, like, because of the stealth fighter jet style, we combed through a lot of the Skunk Works, which is a Lockheed Martin, like, super top secret stealth fighter jet project umbrella. And we started hunting for names that maybe stood out from that. And then we also went tunneling into different folklores. And Norse mythology is always cool. Thor has already been a robot, so that wasn't going to work. I'm trying to remember what other options we had for names.
I always thought, basically the way I see it is like Valkyrie, kind of, there were 3 different intersections of things that led to the name Valkyrie. One, the robot is shaped like a V, so we wanted something that started with a V to sort of represent that. 2, we wanted something that was sort of sounded sleek and sounded scary and sounded
Intimidating.
sounded fierce and intimidating. And so that was another part of it. And 3, one of the things was like Leanne being one of the only like female captains on the entire show. That's one of the, like, I feel like that's a big part of who we are as a team. And we wanted to represent that. And so the Valkyries are these female Norse warrior goddesses that would fly down from Valhalla and choose who lived and who died on the battlefield. And sort of that sort of image of like these powerful goddesses coming down and figuring out and like choosing who would go to the Valley of the Slain was like a really great, scary image.
Yeah, and it just sort of rang out as like a name that was going to stick out a little bit more. And once we saw it and started like thinking about it, it just, every name proposed after that, we just sort of, it didn't stand out as much, and so it seemed very obvious like to go with that.
Means we get a theme song too.
Oh yeah, that's the best part, is that we have the whole entire crowd, like hundreds of people singing the Wagner song "Flight of the Valkyries," which is great. I guess like that's it for questions that are on film. We'll obviously be around. We have stickers and stuff because there are a lot of kids here. If you have other questions, we're happy to talk about them. Talk about our fights. We have a lot of debris from our past opponents that are usually gifts. Like that's a regular thing, is if you end up having parts that you can't use anymore, you gift them to the robot that ripped it off of you. So we have a lot of parts. Thank you guys all for coming out. Thanks WGBH everything. Thank you.
Thank you.